This conference will now be recorded.
Hello friends, welcome to bispsolutions.com. My name is Sumit and here with my new video in machine learning with R. And the topic for today's video is how to implement linear regression with R. You might have gone through my previous videos where I have explained about the various machine learning concepts, regression analysis, predictive modeling, and decision tree, random forest in R programming. So this is my new video, and in here I'm going to talk about performant linear regression in R. So what exactly linear regression is? So basically linear regression, this is one of the simplest mathematical relationship between two variables x and y, and we used to denote it as a linear regression. Basically, linear regression is used to, it's a method for predicting the value of a dependent variable which we denote as y based on the value of an independent variable denoted as x. And the formula for calculating linear regression is y is equal to mx plus c, where y is the independent variable, sorry, y is the dependent variable, m is our slope, x is the independent variable, and b is the intercept. So let's begin and have a look at how can we implement a linear regression analysis, linear regression on my data set. So that's the data set which I have extracted from live website, and this is my financial data. Here I have columns like revenue, cost of revenue percentage, gross profit, marketing expenses, and so on. So my objective is to demonstrate whether when my revenue is increasing, my gross profit is increasing or not. So I just wanted to demonstrate this with the help of graph. Also, I wanted to predict a value that if my revenue will be this, that what will be my gross profit. So let's have a look. How can we achieve this? How can we make predictions, and how can we demonstrate this with the help of linear regression and plot it using R? So I'm using R Studio for that, and as you can see, I'm ready with my environment. R is installed. My R Studio is ready. So the very first thing I need to do it, I need to load the data, and so here I'm writing syntaxes to load my data, and I'm extracting my data from F drive datasets. If you're not sure about the datasets, I'll just means if you're not sure about the location, so I just copy the location, and my file name is, I'll just look at the file name. My file name is finance data1.csv, finance data1.csv. And let me load this file. When I execute this file, when I execute this command, it says there are 924 observation and 24 variables. Now 924 observations means number of records, and 24 variables means the fields we have. So we can check it out. So when I select this, so there are 24 columns. 24 columns are there, and 925 records it is showing, including the header. So if we exclude the header, then we will have 924 records. So that's the same number of records are loading here, are loaded in this data. And if you want to look at the preview, if you want to check the data, the graphical preview, or you can say the tabular view, we can click on this and we can see the tabular exactly as we used to have in Excel. So this is how we load the data in in R. Now I need to, as you can see in this data set we have 24 columns, but my objective is to work only on revenue and gross profit. So what I'm going to do is I'm going to extract those columns and store them into separate variables. So I just store them into separate variables as revenue, and I'm just write gross profit is equal to data dollar gross profit. And when we execute this, we'll get two values. One is gross profit, revenue, number of observations, 24 observations, 24, 924 observations, 924 observations. It means both revenue and gross profit contain equal number of records. If you want to check the type of it, so we can check the type, what's the type of this revenue field. So the type of revenue is numeric. And in same manner, if I want to check the type of gross profit, which we have created with a variable we created, so its type is also numeric. I'm just going to comment it. We can use hash sign to comment, to mark a comment. Now I need to plot this on a relation so that we can extract the slope and the intercept. There are two ways to do that. Either we write the complete algorithm to calculate the slope and the intercept, but in R, there are pre-built functions, and that function is known as LM function. So that LM function will help us to extract the slope and the intercept based on the given data. So let me plot it like this. So I just write relation and I just write LM, and I want to extract the slope and the intercept where the gross profit is the dependent variable. This is my dependent variable, and my revenue is my independent variable. So as I have already mentioned that I would like to figure it out whether my profit is increasing when my revenue is increasing, and I want to predict the gross profit based on the revenue. Therefore, I just write here gross profit with respective to revenue. And when I execute this, we are getting relation list 12. And if I just print relation, if I just print relation here, I would be getting the intercept and the revenue. So we are getting the coefficient, intercept, and the revenue. So that's my slope and my intercept. So that's my slope and that's my intercept. So my intercept is coming in negative because I have got a lot of negative values here. I might be getting a couple of values. So yeah, sorry, that's in a different anyway. So that's perfectly fine. So that's not an issue. It calculates automatically. And if you wanted to extract it more, if you want to check it more, just click on relation and you will see more details about it. When when you click on it, you will be getting the coefficient is here where we have intercept and revenue. The residuals are here. The residuals based on all 924 columns. So this residual will be on all 924 columns we have. And the fitted values. So this calculation is done based on 924 records. And the formula we use is gross profit with respective to revenue. So that's the formula automatically done, and it automatically creates a data frame. So the data, when we pass a data to this formula, it automatically converted into a data frame. So it automatically creates a data frame out of it. Now I want to make a prediction. So this is, I got slope and intercept. As I've told you about, the formula is equal to y is equal to mx plus c. We got x, we got m, we got c. Now we need to make a predicted value for y. So I just write A and I just write data dot frame. Why I'm passing a data dot frame? Because as you can see, the value gets stored in the form of a data frame. So that's why we have to typecast it, and the value we are passing that would be stored as a data frame. And I would like to calculate the gross profit if my revenue is 3,456. So I just created a variable, one observation, one variable, and now we are going to make a prediction. And for prediction, I just write result, use a predict function, and I just plot relation comma a. And when we plot this, we can see the result is 2086. I can simply print result, and when I print result, I got 12086.307. So it means if my revenue is 3456, my gross profit will be 2086.307. So that's the way how we can predict a value, predict predict a dependent variable based on independent variable. Now, my final objective is to plot a graph for same so that we can easily demonstrate this to our end users. So I'm using a plot function to plot a graph, and I'm just plotting gross profit I'm keeping on y-axis, revenue on my x-axis, and I set color is equal to blue. And when I plot this, when I execute this, you can see a plotting has been done. This is the values have been plotted here. The values are so close because there is not much difference between the values. So now my requirement is I would like to plot a line over here. So I just use a function called AB line, and I use LM regression line revenue with respective to revenue gross profit, comma CEX is equal to 1.3, comma PCH is equal to 16, comma X label is equal to on X-axis we are plotting revenue, and on Y-axis Y label we are plotting gross profit. So let's plot it once again, and we can see a line has been plotted. Let me try to plot a color also. So color is equal to red, and let me check it. So you can see we plotted with a red color. This says that it's a regression line, and gross profit versus revenue. So this need to be changed actually. This should be gross profit with respective to revenue. So we just plot it out, and yeah, we are getting the values perfectly fine. So that's the way how we can plot a graph. So that's the way we can plot a graph, and yeah. So that's the final graph, and I made some changes. So what I did, because when I add labels, so my labels was not coming properly. So I just changed the labels. On my x-axis, I want to plot revenue, and on my y-axis, I want to plot gross profit, which because I so which clearly demonstrate that when my revenue is increasing, my gross profit will also be increasing. And I just change it over here. Plot. I just plot revenue on x-axis and gross profit on y-axis, and rest of the things are same. So that's the you can say that's the code for uh, plotting this graph. We can also export this in a PNG file, or like here we already have an option. We can export this. So I can export this directly as an image or as a PDF, and we can share this with our end users as an attachment on email, or we can directly add it on our website. So that's the way we can create a regression line. We can plot a regression line, and we can predict the values. We can predict the values, or we can predict the gross profit depends on the revenue. So that's all in this video. I hope you found this video interesting. If that's so, don't forget to press like button, and you can post your comment in comment box. You can contact with us for the customized training on R programming. Thanks for watching. Have a nice day. Goodbye.